Well, hello there, my dear jungle friends, and welcome to another fun-filled day in pure paradise, my friends. And what? What's that? What? My image is coming through the computer? Wait. Hey, I've always hidden my picture, and they could only hear my voice. You mean they can actually see me now too? Oh, sorry, I had this new tech crew. They didn't quite inform me that I was actually going to be. Okay, whoa, this is embarrassing. Hi guys, how are you doing? Yeah, okay, should make sure. Okay, my hair look neat. All right, hey, you're getting me live from my residence this particular math lesson, and I'm playing around with some technology that I've had for a little while. So anyway, I know you're probably kind of saying, "Gee, Mr. Ward, this is kind of freaky, but let's do the math lesson, guys. Okay, you're getting me live, voice with the image. Okay. Now, first thing, let's get a good pen here. I like this one. Okay. It says the objective here is we're going to solve a two-word problem. Two-word problem, two-step word problem, and it's going to involve measurement and multi-digit multiplication. Now, if you recall, I know you guys are staring at me. Okay. Hey, you know it's not nice to stare. Just kidding. Hey, it is a review here, what we've been doing with this multi-digit multiplication. So what we're going to do is just keep building upon some of those things that we have. So let's go ahead and do some fluency practice. And if you recall, we did some different stuff like estimating and finding easy ways to find quotients to the division problems. And one of the things that we looked at is we realized that, that one of the things we can do is we can actually look at the number and see that this not only is both by a power of 10 here that you can completely divide out, giving us 24, making this very easy to solve. 480 divided by 20 seems difficult, but when we divide that power of 10 out. But there's other ways that we can look at that. There's many different patterns here. We have, for example, like 390 divided by 300. Well, we could actually look at this problem in another way, because here you can see 300's got two powers of 10, but we could also think of this is like 690 divided by, and we have our 100 divided by 3, because here 300 is, okay, 3 times 100. So we could divide out the 100 and then divide out the 3. This makes it a little bit easier. Now, we only have 1 power 10 here, but we know the decimal place will move. So in this case, it'll move twice, giving us 6.9. By being able to divide that 100 out, now we simply have 6.9 divided by 3. Much easier to solve. If you'd put this 3 on this other side and think of the division, 3 is going to go into 6 just 2 times, and it's going to go into 9 3 times. Therefore, 2.3. A real quick way to address a problem that normally just by looking at would be very difficult to solve. And this is going to come in handy in some of the lessons that come in the future. So, how are we doing? Okay? Yay. All right. It feels kind of weird. I'm staring at this camera like, hello there. Where are we at now here? Let's go ahead and move on to the concept development. I do believe that's the next page. Click. Ding, there we go, and the problem's all ready to go. Look at that. Mr. War is so organized, or so he thinks. Let me see here. Get a pen here. Ooh, I like this one here. Ooh, a lot. Anyway, it says here that Lisa's cat had 6 kittens. Woohoo! All right. Now, it's really important. Lisa and her brother weigh, okay, all the kittens together. That seems important. I'm going to circle that. Woohoo! There we go. And it says they weigh 4 pounds 2 ounces. If you recall, you were doing some of this converting, so that should be familiar to you. There are, let me just write this down, 16 ounces, if you remember, in 1 pound. Oop, there we go, a little abbreviation. That's going to disappear. Now, please don't be confused. That has nothing to do with that special word that I look for every time. Since all the kittens are about the same size, how many ounces does each kitten weigh? So it looks like we're just going to do an average. They're not going to be exact. So when I look at this problem, immediately I kind of think, well, I'm taking 6 kittens, and my thinking is telling me that I need to find equal groups. So there's going to be an amount that's going to be the same, that you could add all those 6 and then it's going to come to your total. Oh, wait a second. I take that back. It says they weigh 4 pounds. Altogether they weighed that, so that is correct. So let me go ahead and come back up here. and look at this. So this is what they weigh all together. So then I'm going to go ahead and take this. Now I have a problem because I have 4 pounds and 2 ounces, and well, the truth is that I can't use both unit of measures. But let me go ahead and bring in my friend here, little chart that I made here, and open up. Thank you very much. Whoo, it's like a fan. Just whoo, I am telling you. Now, so right here we can kind of think of it this way. This total amount here, let me see if I can do a bracket, okay, is the 4 pounds, okay? I'm going to write right over this problem, and that's going to be my 4 pounds, 2 ounces for all 6, okay, all together. And basically what I'm trying to find out how much each one weighs. So it's like one of these I need to know how much it weighs. So it's like I'm taking that total amount and I'm going to divide by 6. Doesn't that seem the most reasonable thing to do here? So first thing though, we need to take our pounds and we need to convert that into ounces. Now you may recall that there were the 16 ounces in 1 pound. Therefore, 16 ounces times 4 pounds would give me the total ounces. Okay, and that's 4, carry the 2, 4. Looks like 64 ounces, I believe. Kind of just did that in my head, but you guys could go ahead and do the math. Okay, 24, carry the 2, then we get our 64. Now, that gives us, good, 64 plus the 2 ounces, now we have 66. So basically, we can say that we have a total of 66 ounces, okay? And now what we can do is we can go ahead now and divide that by the number of kittens that we have here. That'll give us the weight for each one. So we're going to divide that by 6. Well, that's not even really a division problem, is it? So that's 66 divided by 6, which equals 11, which means this here will be 11 ounces. So now we can say that, and then when we think of these as like a unit. When you see that come up, so that 1 unit right there would be 11 ounces, because each one of these would be 11, therefore giving us to our 66. I don't know. Does that kind of make sense? I hope so. Anyway, let's go ahead and see about doing another problem here. Okay, I'm trying to go through these fairly quickly because I don't want to be up here too long. So let's go ahead and, do I have the written problem here? I don't, which means I have to get busy here typing. All right, and so let's say we have Holly. Whoops, let me come down here. And let me come down here really quick. Maybe there's another option here. Let's do this. Let's hit pause. Okay, I did that. I kind of stopped and went ahead and typed up our problem to save some time here. So this way. So now it says that Holly is buying orange juice for the class party. There are 24 people coming, and she figures each person will drink 1.75 cups. Okay, now it also asks, the question that we're going to be faced with here is, it says how many fluid ounces of juice will she need? Now, if you remember, that fluid ounces just refers to the kind of the liquid for volume. So anything of a liquid form would be fluid ounces as opposed to regular ounces, which are based on weight. And this is not. So, well, let's take a look at this. Let me go ahead, and when I'm thinking the problem, it's important that I reread the problem again and again if I don't quite understand it. So when I look at it, it's like Holly is buying orange juice for the class party. There are 24 people coming, and she figures each person will drink 1.75 cups. So to really get a good understanding when you look at this, so let's go ahead and I'm going to underline that 24 people are coming, and each person, this is key here, will drink 1.75 cups. It says how many fluid ounces of juice will she need? Well, when I think about this, I'm thinking that we need to take this kind of 1.75 cups and give it to one person, and then another person, another person. So when I think of that, I'm thinking of go ahead and grabbing this little tape diagram thing here that I made. Okay, so you can see this. So when I look at the problem, you can see that what I'm going to do here is I'm going to go ahead and write in here in this little box. I'm going to go ahead and put, well, this is like one person drinking the 1.75 cups. Okay, and of course that's going to be another person here, and another person here. Now I can't do all 24. I wouldn't have all the room, so that's where I'm going to do, just do my dot 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 dot, and then of course it's going to be ending at 1.75 cups. So now this would actually refer to the entire amount then of how many cups I'm going to need if I do my bracket, which we don't know how much that is. But what we do know is that 1 unit, we keep referring that to 1 unit, which is one person here, is going to be 1.75 cups. Okay, and it just so happens that we also know that then in order to determine how many cups we're going to need for 24 people, you can see that we'd be doing some multiplying here. So what I'm going to go ahead and do is get another pen, and we'll go ahead and take our 1.75 and multiply it by 24. Okay, now this is the way that we can figure out this problem and find out how much we're going to need altogether. So now I have my multiplication. 20, carry the 2. Okay, now I have 28. That would be 30. Carry the 3, 4, 7. Now I'm going to put in my placeholder. So my 2's lined up nice. 10. I'm going to carry that 1 there. I have 14, and 1 is 15. I'm going to carry that 1, 2, and then what is 3. Now I'm going to go ahead and add my numbers, and I have, looks like 4,200. Oh my goodness, that seems like a lot of cups. But wait a second, we have a decimal place here that needs to come out. We have 2 decimal places, so we need to take those 2 out and put 2 in like that. A caveman could do this. Actually, I'm part caveman, so no. And I could do it, so that's showing some. So 42, does that seem reasonable? 42 cups? Well, it looks like about 2 cups per person. And if I double 2 times 24, that's 48. Yeah, that's pretty close. That answer seems very, very reasonable. So this now we know is going to be 42 cups. Okay? So that's the key here for finding that. Now, this is how many cups it says. Now, the problem is that it says how many fluid ounces. Oh, so I'm not done? Really? Okay, because fluid ounces aren't cups. Now, we have to remember that we actually have we have to convert the cups. Now, I believe a cup, I sure hope so, I believe is 8 ounces. I should look this up. 8 ounces, I believe, is 1 cup. I'm going to stay safe with this. And we'll stay with that number, and you guys can tell me later if I was incorrect. But the process is the same. So if I look at this 42 cups and the 18, carry the 1, that's 32, 33. So I end up with 336 fluid ounces. I missed my calligraphy pens. Anyway, so there you go, and that would be fluid ounces. And then we've met the... Now I'm going to go ahead and stop us off here. Basically, we've completed everything. There is something that you need to know, and that, of course, is always to put in the secret code. I can't give you credit for the assignment otherwise. And I think that completes it. So, see you in class.